A VLAN is a method to segregate different ports or isolate different ports on a switch. So you can say that port 1 through 6 is on one VLAN and 7 through 12 is on a different VLAN. But VLAN also refers to a special tag, a special field inside the packet. A tagged packet can tell the switch which VLAN this packet belongs to. Now, not all traffic that goes through a VLAN switch will be tagged. So in a case where there's different LAN going through a port, you know that these packets are this VLAN and these packets are that VLAN. The second part of the question is, what issue can we encounter when we plug in unmanaged switches on a VLAN tagged network? It becomes really unpredictable and undocumented behavior. Now, most unmanaged switches today will just transparently pass all traffic, whether it's tagged or not tagged. But that's not guaranteed. Because an unmanaged switch is exactly what it sounds like, it has no awareness of VLAN, it can create unexpected distribution of the traffic. Now, again, in general, an unmanaged switch will just pass whatever comes in, but just be user aware that it's not guaranteed. Inside this VLAN field is this number that's called the quality of service bit. So it allows you to set a value between 0 and 7. 7 is highest priority and 0 is the lowest priority. In general, if a 2 packet came into the switch at the same time, it should take the higher priority packet first and then the lower priority when it has time. Let's say you had a few devices of much higher priority than other devices, your air handlers, for example, and you know that you're running in a system in a network that is quite busy. You could configure the ports connected to these air handlers to tag the traffic of a higher priority so that as the packets come in with all the lower priority packet and it hits the bottleneck, it should pass the traffic for the air handlers first. But it requires a tremendous amount of management of configuration to make this work. Really, the advice in this example would be to fix the way your network works or your application works so you don't run into these bottlenecks. VLAN is very, very good in the IT world. In the IT setting, it's very, very bursty. There's a lot of unpredictedness to the network, to the system. So that's why you want to be able to play around with these quality of services. But in the operational technology system, it is highly recommended to not design what we call an oversubscribed system, an oversubscribed network. Therefore, quality of service bits in these cases should not come into play. Network isolation, network segregation is a little bit of an art more than a science. So if you have this system that's very, very bursty, a lot of broadcast, and this other network doesn't need to communicate with it, then put on 2 different networks and allows the noise from one network not to interfere with the other network. Another thing is security. Let's say you have 2 vendors and they do not need to work with each other. Their devices do not need to communicate with each other. Why put them on one network and have one vendor make a change that causes an issue on a different system, unrelated system? So that would be another good use of VLAN, for example, create these isolations. In building automation, we often hear designs where, we'll put every floor on different VLAN. Well, that's not necessarily the best way to do it, because if there is cross-floor communication for different air balancing, then every time there's communication between 2 VLAN, it has to go through a router. So you're creating the single bottleneck. So sometimes creating VLAN by function is a better approach. So in a hospital setting, for example, I think probably one of the main consideration would be what service needs to communicate with other service and what service should be separated from others. That one reduces the likelihood of issues crossing over. A fantastic question, because this question crosses over between knowledge of IT systems and knowledge of building automation BACnet systems. So first of all, let's back up a little bit. BACnet discovery requires uses these messages called who is and I am. QoS are broadcasted messages. And that's how it allows one device who doesn't know where the other device is to discover where that target device is located, what the address is, and how to get there. And then the reply uses a message called I am. If you create one large BACnet system with, say, 1,000 devices, and these devices are configured to send out a QoS every 15 minutes, well, you'll get this broadcast arm. You'll have every device send a QoS, and then it will create this massive broadcast arm going everywhere. Now, if we created smaller islands, subnets, VLANs, 250 devices, now you can see how even if all 250 devices were sending out this broadcast QoS at the same time, your peak is smaller. So by reducing the amount of broadcast, you can improve the performance of your overall system. And that's why in Optical Visual Networks, we have a diagnostic called Global Discovery. Global Discovery looks for these QoS that's looking for a very large range, or it can be also very large range. I would have to check the documentation, but it's either a range of 1,000 and above, something like that. So, but now to continue on this question here, reducing the size of these VLANs will reduce what we call the broadcast domain. However, when we look at BACnet systems and we now add the role of a BBMD, BBMD allows BACnet broadcast traffic to cross over from one subnet to another subnet. But when you put two BBMDs on each side, you're now taking all that broadcast from one network into the next network. So now instead of creating broadcast storm, you're creating a bottleneck through the BBMD. So that's where you have to have that balance of don't make it too small, because then you have a tremendous amount of BBMD, much more likely to make mistakes. But you make it too big, and now all that broadcast traffic from this subnet of VLAN A goes through that one BBMD. And also combined with that topic of what we call. So finally, if you're asking for my rule of thumb, I would recommend networks less than 1,000 devices each, and make sure that you monitor or you measure the amount of broadcast traffic, BACnet broadcast traffic in those subnets. You don't have to do it constantly, but do it once in a while. On that note, I recommend less than 1 packet per second of BACnet broadcast on an average. So less than 60 BACnet broadcast packet per minute.